Hello everyone. Today we discuss advanced Spark programming. We introduce two types of shared variable. One is accumulator. It aggregates information. And the broadcast variable. It distributes large values to the data nodes. Then based on the interaction of Spark with external programs, we will talk about pipe to external programs written in other languages. And also we will discuss the numeric RDD operations. We first look at the accumulator, which is a shared variable. A shared variable means the variable is shared across the worker nodes. It's used for aggregating values from worker nodes back to the driver program. It's commonly used as a counter to count the events that occur during the job execution. This reminds us the counter for MapReduce, right? But here it's much simple for us to implement in Spark. The accumulator works in 3 steps. In the first step, we create the accumulator and give it an initial value. This is done by calling the Spark context.accumulator method. In the second step, the worker node in Spark add to the accumulator with the appropriate value. Then in the third step, the driver program can call the value property on the accumulator to get the value. Here is an example of accumulator. In this example, we are loading a list of all the call signs. At the same time, we are interested in how many lines of the input file were blank. Here, the blank lines is created as the accumulator, and it's initialized to 0. And in this function, extract call signs. In this function, we can see there is a global variable defined, the blank lines. The global variable in Python is that whenever there is an update, it's a global update. It's not only within this function itself. Okay, then in this function, if the input line is a blank line, then this blank line accumulator is incremented by 1. And this in this call signs RDD, it's using a transformation flat map and apply the function extract call signs on the RDD file. When this transformation is called, it will run this extract call sign function, apply this extract call sign function on each line of the file RDD, and that will increment these blank lines. Here are some notes. In this example, the function to increment the accumulator is called in the transformation flat map. Recall that the transformations are lazy. Only when we run an action, the transformation will start to work, and the count will be updated for the accumulator. And in this example, we count the number of lines of the input file with blank. We can also use an action like reduce to accomplish the same goal. while the implementation using an action is different from the accumulator. The accumulator aggregates in the transformation, so it's simple and at different scale. For example, if we want to count the errors when loading the data, and this can be easily accomplished by the accumulators, while in the reduce, the error has already been processed before it reaches the reduce function. And using the accumulator, it's very handy to keep track of multiple values. Here is an example to use two accumulators, valid sum count and invalid sum count, to keep track of the total number of lines with valid and invalid sums. And this is incremented in the valid sum function, which is called in the filter transformation. And we can see that and using the accumulator, this is very flexible and actually very simple to keep tracking of the numbers we want to count. Spark has this fault tolerance mechanism. It will automatically deal with the failed or slow machines by re-executing the failed or slow tasks. Then how does this interact with accumulators? For accumulator used in actions, Spark applies each task's update to each accumulator only once, and it's a reliable absolute value counter. And for the accumulator used in transformations, there is no guarantee that the counts are absolute value count, because accumulator update within a transformation can occur more than once. And if there are multiple machines running on the same task, they will all be updated. Because of this reason, for accumulator in transformations should only be used for debugging purpose, because they do not generate the exact numbers, but that number is close enough for us to debug our data. Now we have used one of the Spark's built-in accumulator type integer with addition. Spark also supports accumulators of double, long, and float. In addition, Spark also includes an API to define custom accumulator type and custom aggregation operations. In order to use the custom accumulator, we need to define a class to extend accumulator param. On the right side, this is an example. A class string accumulator is defined, which takes the string as the accumulator type and defines the aggregation for two strings. Broadcast variable is another shared variable in Spark. Different from accumulator, which accumulates the value of a small variable. Broadcast takes care of the large read-only variables and send them to all the work nodes. A broadcast variable is an object of the broadcast in Spark package. Well, here with the broadcast variable, we can send some data to the worker nodes. we can also send data in the format of an object from the supporting language. Here is an example for the broadcast variable. In this example, the SAM prefix is the broadcast variable. It includes the country's prefix and the country's name. And in this process SAM count, in this function, it uses the values stored in the SAM prefix values. And this process SAM count function is called in the map transformation for the contact counts RDD. Okay, so for the map transformation, it processes every line of the RDD. While for the broadcast variable, it will be sent to a data node once. And this SAM prefix broadcast variable we need to maintain it read-only. If we make change to it, it will not be updated on the data nodes. As shown in the example, the process of using broadcast variable includes 3 steps. The first step is to create a broadcast object. The second step is to use the value property to access the broadcast variable's value. And the third step is this variable will be sent to each node only once. Spark supports Python, Scala, and Java. Sometimes we want to use other programming languages, and Spark provides a pipe method on RDDs. It allows us to write part of the job in any language, as long as it can read and write to Unix standard streams. This is helpful when we already have some previous code and we want to use them in the Spark with the RDD's content. And a lot of data scientists have code in R, and we can interact with R programs with pipe. Of course, we can also use other languages as long as they can satisfy the Unix streaming requirement. Here is an example of using pipe to interact with R programs. This first part of the example is an R script. It uses an R library to compute the distance for all of the contacts. This is the second part of the example, which is a driver program in Python. It uses pipe to call the findDistance.R. We can see that the Spark context object SC it adds file given the path to the R script, and in the pipe function, the Spark files get the name of the R script, and in this way, the R script will be utilized in this Spark program. Numerical RDD operations. Since the statistics of numerical data are important to get to understand the data and helpful to analyze the data in many ways. So Spark has this built-in descriptive statistical operations on numerical RDDs, and the common statistic operations are all computed in a single pass and return as a stats counter object. The stats counter object includes the commonly used statistics, and here is a list of those statistics available. Here is an example of using the statistical counter to get the useful statistics from a numerical RDD, and this example finds the outliers and remove them from the RDD. So here the distance numerics is an RDD, and its statistics are obtained. Then from the statistics, we can get the standard deviation and the mean of this RDD, and then we compare a point in the RDD with the mean and the standard deviation. If this point is far away from the mean, then it will be considered as the outlier, and we only keep the data within 3 standard deviation from the mean. Also, sometimes we only need to use maybe one of the statistics. We can call that method directly. For example, RDD.mean.